Hello students, today we're going to learn about transformations of exponential functions. We're going to start with example of vertical translation.
How does the value of k affect the graph of f of x equals 2 to the power of x plus k?
¿Cómo afecta el valor de k a la gráfica de f de x es igual a 2 a la x potencia más k?
Now, let's pay attention to the essential question of the lesson. How do changes in an exponential function relate to translation of its graph? So this is going to be the essential question for this lesson. In this case, we have the value of k affect the graph of a function fx is equal to 2 to the power x plus k. So plus k is the constant. We're going to see how the graph is going to transform after we add the value of this in here. Now, compare the graphs. G of x is equal to 2 to the power of x plus 3, and j of x is equal to 2 to the power of x minus 3 to the graph of function of x is equal to 2 to the power x. Now, as you see, this is the original function. So this here is the original function. And the graph is in here, fx. So this is the function of x is equal to 2 to the power of x. As you see here how it... Now, we're going to see how this graph is going to be transformed by adding this constant here. Let's see when we add a number, when we add a constant, what it happens to the graph. Let's see here. So it says that the graph of fx is equal to 2 to the power of x plus k is a vertical translation of the graph of fx is equal to 2 to the power 2 to the power of x. If k is positive, so if k is positive, so in this case here, k is positive, the graph is moved up. So the graph is moved up. Let's see how it's going to behave in the graph. As you see here, this is the original function, the exponential function, the original exponential function. Now, if it says it's going to transform, it's going to translate of the graph, is going to go up, how many units will go up? Let's see here. As you see here, translation is 3 unit up. It goes 3 unit up. So it's 1, 2, 3. 3 unit up. This is a translation of this graph. Let's see what happens when we add a negative integer. So a constant is negative. Let's see what happens. Let's see, I'm going to erase the g of x so you can see the j of x. The j of x, it says that the graph of function x is equal to 2 to the power of x plus k is a vertical translation of the graph of f of x is equal to 2 to the power of x. Now, this is the original, as previously we said, this is the original exponential function. Y is equal to 2 to the 2 of the power of x, and how is going to translate. If k, it says here, if k is negative, as in this case is a negative 3, the graph is moved down. So you're going to see that it's going to move down 1, 2, 3, and it's going to come here to negative 2. Let's see if this is true. Let's check it. Yeah, so translation is 3 unit down. It's very important to pay attention to this, to the transformation, to the translation, how it translates, so how it goes up and how it goes down with the constant. Okay, now let's see both graphs. Let's see both graphs in one. Okay, it's not letting me. Okay, all right. Let's see, maybe it does. No, it's not letting me go both to see the both graphs, but you have the idea now. When it's positive, moves up. When it's negative, goes down, moves down. Okay. Now, vertical translations.
Part A. How does the graph of g of x equals 2 to the power of x plus 1 compare to the graph of f of x equals 2 to the power of x?
Okay, now pay attention. What is the original function? The original function is f of x is equal to 2 to the power of x. This is the original function as we saw in the previous slide. Now, what's happening to the function? You add in 1. If we add 1, what happens? So translation is going 1 up, right? It's moving up. Let's see. It's moving up. It's moving up. Let's see the answer. Okay. Answer A is g of x is a translation 1 unit up from fx. Now, it's very important, from fx, to make a complete sentences. So as you see, we move to the translation 1 unit up from function of x. Let's see what's happening with the second one.
Part B. How does the graph of j of x equals 2 to the power of x minus 1 compare to the graph of f of x equals 2 to the power of x?
Okay, in this case, jx is, okay, in this case, jx is a translation on 1 unit down from fx. So let's see, jx, so function jx, okay, is a translation 1 unit down. 1 unit down. Okay, let's see. It's a translation 1 unit down. Correct answer. So jx is a translation 1 unit down from function of x. All right. Let's move to the next one. Let's see some additional examples so we get better practice. So always paying attention to how do changes in exponential function relate to translation of its graph. So you can see the patterns. You can see what happens when we add positives and when we subtract something from the function. How the vertical shift it happens. The function of f of x is equal to 7 over 3 times 23 over 5 to the power of x is translated down 6.9 units. Write the equation of the new function. All right. This is okay. Okay. Let's see now. For some reason it's not okay. Let me go back. Sorry guys. Something is here. I'm not. Okay, it does. Okay, let's go additional. Let's try some additional examples. The function of fx is equal to 0.5 times 0.25 to the power of x is translated down 65 over 17 units. Write the equation of the new function. Now, you don't have to get scared. You see fractions, and I know everybody gets, this is hard. It's the same thing. Just follow the structure as we did in the previous slides. Let's see now. Here, it says it's translated down. If it's translated down, remember the key words. It translated down, we moved down these units. So it's going to be subtraction. Let's see. That's correct. So we subtract 65 over 17. Let's try another one. As you see here, we wrote the original function, and we just subtract the constant 65 over 17. Let's try another one so you get comfortable doing this. The function of fx 7/3 times 23 over 5 to the power of x is translated down 6.9 units. Write the equation of the new function. And is translated down again. What does it mean? How is translated down? What do we do? So again, we just minus in the function, the original function, which is, this is the original function, minus 69. These are type of question, guys. You have to pay attention when you take the quiz. This is exactly questions, just they change the numbers. So pay attention to the translation, the function of fx is equal to 3.68 times 3.11 to the power of x is translated again down 8.02 units to write the equation of the new function. Now we write the original function. I'm giving you the solution here, but you have to know, you write the original function here, which is this one, and you subtract 8.2. Let's try another one. The function of fx is equal to 25 over 9 times 3 to the power of x is translated up 4.44 units to write the equation of the new function. So the new function translated up, what does it mean? To the k value. So we are adding 4.44 units. Let's see solution here. Okay, I think it's good with this example. Just move to the next one. Now horizontal translations of graph of exponential functions. Let's see what happened with horizontal translations. Horizontal translation, as you see now here, the translation is going to happen to the exponent. We have to the exponent, this h value is going to next to the exponent, not to the original function. Let's see here.
Compare the graph of g of x equals 2 to the power of the quantity x minus h with the graph of f of x equals 2 to the power of x when h is greater than 0. What effect does h have on the graph of g?
Okay.
Compara la gráfica de g de x es igual a 2 a la x potencia menos h con la gráfica de f de x es igual a 2 a la x potencia, cuando h es mayor que 0. ¿Qué efecto tiene h en la gráfica de g?
Okay, again, the essential question is, how do changes in exponential function relate to translation of its graph? Let's see now. Now, what does it happen? We're going to see what does it happen. What is the difference between the previous examples that we did the vertical shift, vertical translations. Let's see now what's happening. What's going to happen? Okay, let h is equal to 5. So we're going to give a value of h. So if h is 5, we have to compare the graph of h of gx is equal to 2 to the power to the power of quantity x minus 5 to the graph of fx is equal to 2 to the power of x. When h is greater than 0, very important these points, when h is greater than 0, the graph is translated h unit to the right. The graph of g is a translation of f to the right by 5 units. Okay, let's see now here. Let's see this one here. As you see here, f of x is equal to 2 to the power of x. So this is the original function, f of x. So this is f of x. And this is the gx is equal to 2 to the quantity to the power of quantity x minus h. So it's going to be this one. Now let's see, here is h is equal to 5. Let's see h equal to 5. So h equal to 5, let's see what's happening. You see the shift? So as you see here, when h is 3, 2, 1, 0, 8, it goes, it should, okay, it goes close. As you see, when it goes to 0, h0, it goes to the original function, because if we subtract 0, it doesn't mean anything, we're doing nothing. So as you see, as we approach 0, h0 is going up and approach the original function. As the number increases, the graph goes down and approaches to the x-axis. Now, what do you have to be careful here? Let's see. Okay, step 2. Let me see here. Okay, let me stop at 2. When h is 2, so it's going to be h is 2. Look how the red graph goes, right? You can see that. Now, the common errors. Remember that the graph is translated right when h is positive and left when h is negative. This is the opposite of the effect of subtraction of positive on a number line. Okay, so this was positive. Let's see for the negative numbers. What happened when we have negative numbers? So this is positive, goes to the right. Okay. We're going to do more practice, so we're going to learn this.
Compare the graph of j of x equals 2 to the power of the quantity x minus h with the graph of f of x equals 2 to the power of x when h is less than 0. What effect does h have on the graph of j?
Compara la gráfica de j de x es igual a 2 a la x potencia menos h con la gráfica de f de x es igual a 2 a la x potencia, cuando h es menor que 0. ¿Qué efecto tiene h en la gráfica de j?
Okay, let's see what happens to the shift. What happened to the translation in horizontal line? Oh, let's see here. So if h is equal to negative 3, compare the graph of jx is equal to 2 to the power of quantity x plus 3 to the graph of original function, which is f of x is equal to 2 to the power of x. When h is less than 0, when h is less than 0, h always, we're talking about that, is less than 0, the graph is translated h units to the left. The graph of j is translation of f to the left by 3 units. Use the slider to explore the difference. Okay, so as we see here, you remember the previous slide, we had positives 3 and it went to the right. Now let's see what's happening with this. Okay, as you see, as h approaches 0, it goes to the original function. As h gets smaller and smaller, it goes to the left of the graph by 3 units, by 9 units. Depends how many units. Let's stop somewhere here. Let me stop at -7. Okay, at -7, as you see here, let's count here. Okay, from here, 1, 2, 3, 4, 5, 6, 7. So 7 units to the left. Okay, let's move to the next example. Let's try this one.
Compare the graph of each function in the form g of x equals 2 to the power of the quantity x minus h with the graph of f of x equals 2 to the power of x. What effect does h have on the graph of each? Part A. G of x equals 2 to the power of the quantity x plus 2.
Okay, what do you think is going to happen? It's going to shift left or in the right on the x coordinates. Okay, let's see. So what effect does h have on the graph of each? So as gx, let's see the answer here. Correct answer, gx is a translation 2 units left of a function fx. So it's 2 units left. We go to the left. And what happened with the second one?
Part B. J of x equals 2 to the power of the quantity x minus 2.
Okay, so jx goes 2 unit jx is a translation of 2 unit right of fx of the function f of x. Okay, check the answer. Jx is a translation of 2 units right of fx. Okay, so we go to the right. So these are the examples of the translation of graphs. Let's see another example of 2 different transformation of f of x. Let's see. All right.
How can you compare the properties of G given in the table to the properties of J given in the graph? Both functions are translations of f.
Okay, use the structure. So what do we do? The range of fx, so the range of fx here is equal to 2 to the power of x. If fx is greater than 0, how do different transformation of fx equal to 2 to the power of x affect the range of the function? So the range of the function. Let's see fx, jx, and gx. Let's see the graphs. Step 1. Compare g to f. So we're comparing g to f. The y-intercept to the graph of f is 1. So the y-intercept to the graph is 1. Okay, f here is 1. The y-intercept of the graph of g is 3. That's not given here in the, okay, it is 3. Now the y values for g are 2 units greater than the corresponding y values of f. The asymptote of y equal to 0, so the asymptote of g is 2 units greater, y is equal to 2. So y is equal to 2. Since the asymptote of g is y is equal to 2, the range of g is y greater than 2 as compared to the range of f, which is y greater than 0.
¿Cómo puedes comparar las propiedades de G que se muestran en la tabla con las propiedades de J que se muestran en la gráfica? Ambas funciones son traslaciones de f.
All right, let's move to the step 2. That was a translation just for the problem. To the second one, step 2, compare J to F. So we compare J to F. As you see, as x decreases, so as x decreases here in a J and gets closer to -1, gets closer to the -1 here, it decreases and gets closer to -1. The y-intercept is 0, so the y-intercept is 0 for this. The asymptote of f, so the asymptote of f is y equal to 0. So y is equal to 0, yes, y, so it's here is the point, so y is equal to 0 here, the asymptote. The asymptote of j, so the asymptote of j here is y is equal to -1. So y is equal to -1. Somewhere y is -1. The asymptote of j is 1 unit less than asymptote of f. 1 unit, so it's 1 unit less than asymptote of f. Since the asymptote of j is equal to -1, so asymptote -1, the range of j is y greater than -1, so the range is greater than -1. Since the asymptote of j is y equal to -1, the range of j, so the range of j, so here range are these numbers here on the number line, x-axis. You know that I mean the y-axis, the range will be y greater than -1, greater than, so the range is y values, right, is greater than -1, so -1 is somewhere here and it goes up. Since the asymptote as compared to the range of f, which is y greater than 0, so y here, the range y is greater than 0. Let's see now, let's compare g to j. The graph of g is the graph of f translated 2 units up. So the g, as you see here, the g is going to go 2 units. As you see here, 0, 1, 3 goes 2 units up. If you see, because here is the 1 and it goes 3 units up. Thus, the asymptote of g is 3 units greater than the asymptote of j, and the y value of g are 3 units greater than y values of j. So 3 units greater, so it's going to come up here to this one here. So we go here, 1, 2, and 3 is going to be here. Okay. Let's see another example, or we just stop it in here and review this lesson because I don't want to give you a lot of information. We're going to practice few more problems on this. Take notes while you're watching the video. Take notes and see, and you have to finish the assignments in Google Class.